Good morning, everyone. I have a question for you today. What if you could build an app that streamed movies and television to a massive holographic display that levitates in your bedroom? Or an app that teaches people how to cook in their own kitchens, only they don't have to find space on the kitchen counter for a laptop, and they don't have to worry about getting a touchscreen wet or dirty. Or maybe an app that helps musicians perform from sheet music without missing a beat, because they can turn from one page to the next just by looking at it. All of these things are possible on Microsoft HoloLens today using two-dimensional Universal Windows Platform apps. My name is Dave Lindsay. I'm Program Manager on Microsoft HoloLens, and today I'm going to show you how you can do all of these things. In this breakout session, we'll cover how you can bring new and existing two-dimensional universal apps to HoloLens. This session does not cover three-dimensional holographic apps, so I'm afraid if that's what you're looking for, you're in the wrong place. This will focus on two-dimensional apps, like those built in XAML and HTML. Some of the things we'll cover today include, first off, why would you want to build two-dimensional apps for HoloLens? I'll show you how some of HoloLens' unique capabilities make two-dimensional apps really special and different. I'm sure this audience is also pretty familiar with the Universal Windows Platform, but we'll give a quick overview of that to make sure we're all on the same page. Then I'll give you a quick crash course on how to interact with two-dimensional apps on HoloLens so that you know how your users will use your app so you can make it the best experience that you can. Then we'll get to the really fun stuff, which will be design considerations. How to actually optimize your app to be the best that it can be on HoloLens. And in this section, I'll give you a live code demo of a universal app running in the HoloLens emulator. I'll show you how you can start testing your own universal app on the emulator for free today. There will also be times where you need your app to behave a little bit differently on HoloLens versus another Windows platform. I'll show you how you can do this without forking your code base and creating multiple versions of your app that you have to maintain. And lastly, we'll dig into how to actually distribute your app through the Windows Store on HoloLens. So first off, why build two-dimensional apps for HoloLens? You might be wondering, it's a three-dimensional device. It's all about viewing cool 3D things and holograms, right? Well, that's true, but HoloLens has a lot of unique capabilities that actually make two-dimensional apps really special as well. Start with, your apps aren't trapped inside of a screen that you have to physically carry from place to place, find a counter to put it on. You can put the apps where they matter to you the most in the world. I keep entertainment apps in my living room, and I keep cooking apps in my kitchen, and I keep productivity apps in my office. It's also really great that you can use HoloLens to interact with apps from different postures. Think about it for a minute. Every digital device you've ever used has a natural posture baked right into it. When you use a keyboard on a laptop or a desktop PC, you are hunched over it at a desk. And when you use a phone, you're holding it up to your face. Even when you're enjoying a big screen experience, you're lying back on a couch. These devices all have postures designed right into them. HoloLens is the first device you will use and the first device you will develop for that spans all of these postures and many more. There's also a lot of great possibilities with hands-free computing. You interact with HoloLens using gaze, gesture, and voice. You don't have to hold a device. You don't have to hold a mouse. Your hands are free to continue interacting with the world. Now, a great example of all of these would be recently I was working on my car. I'm not a particularly good mechanic, so I need the service manual handy with me. So I had the engine bay open on my car, and I had a service manual, and I had a wrench, and I had another wrench, and I was trying to work on it, and I couldn't read the service manual, so I stuffed a flashlight in my mouth, and I was bent over the engine bay, and it was a disaster. I ended up getting the service manual all dirty with oil and brake dust, and it didn't work very well. And then I realized, I'm living in the future. I have a HoloLens at my house. So I actually went back and I got it, and I found a PDF version of my service manual. I went back down to my car, and I placed that PDF in the engine bay of my car, bent over the engine bay in a location I could normally never use a computer because there's not a good surface to place it on. And I was able to continue reading it. It's completely illuminated. I was able to continue reading it while using both of my hands and focusing on the task at hand. And this was really a great moment for me when I realized some of the possibilities that you can have with universal apps on HoloLens. HoloLens is so much better at multitasking between the physical world and the digital world than any other device I've ever used. Now, the last reason why you should be developing two-dimensional apps for HoloLens is that it's actually incredibly easy. We've been investing very heavily in the Universal Windows platform, and it's very easy for you to bring your apps to HoloLens. I'll show you how to do that with the emulator in a little bit. So, quick overview of the Universal Windows platform. I'm sure you're all familiar with it by now. So, the Universal Windows platform is a common platform that all modern Windows devices are built on. The idea is that you can build your app for it just once and ship it to hundreds of millions of devices. Now, this talk is going to focus specifically on HoloLens and how to bring your new and existing two-dimensional apps to HoloLens. But a lot of the techniques that I'm going to show you will also apply to the other devices, too. So as I said, we've been investing really heavily in the Universal Windows platform, and the goal is really to make it easy for you to bring your universal apps to HoloLens. It's also made it really easy for us to bring our universal apps to HoloLens. So these are some of the apps that you can expect to find on the device when you get it. You can go to the Windows Store. You can download OneDrive and get all of your files and photos anywhere in the world on any device. You can use the Xbox app to stream games from your console to a hologram in your living room. I'm probably the first person in the world to do their taxes on holographic Excel. And actually, yesterday, I was reviewing this exact deck in PowerPoint on my HoloLens. And you know every new Windows platform has made it when it has Solitaire, because every Windows platform has Solitaire. So about interacting with two-dimensional apps on HoloLens. It's very different from any other device you've used before. As I mentioned, you place apps and holograms in the world where they matter to you most. They're not confined to a screen. And you don't use a mouse and a keyboard. Well, you can if you choose to. You interact with gaze, gesture, and voice. Last year at Build's keynote, my friend Darren gave a quick demo of exactly what life with holograms could look like. Here's a short clip.
Now, when we introduced Windows Holographic, the globe was just a slide. Today, Darren is experiencing it as a universal Windows app. And guess what? It's running on Windows 10. Welcome to Windows Holographic. This is life with holograms. And as you can see, Darren has customized his space. Instead of digging through menus, everything is right where he wants it.
Yeah, whether it's Microsoft Edge, Photos, or video apps, these are simply universal Windows apps that we've placed as holograms. So whether it's a slate on the wall or something a little bit more dimensional, like my loyal companion Fang here, hey buddy, you can customize your space the way you want it. Now I want to add something to my space, so I'm going to pull up my holographic start menu, and I'm going to open up Skype. I'm the worst at keeping in touch, so I'm going to take the people that matter most to me, and I'm going to pin them to this wall right here. That way, every time I walk into this room, I'll see their smiling faces and be inspired to reach out to them.
OK, so that went pretty fast, but don't worry. I'm going to give you a quick crash course on how to use HoloLens with gestures. The first thing that you need to learn when you put on HoloLens is what we call the bloom gesture. This is how you open the start menu. Just place your hand in front of you. You don't have to reach way out, just comfortably in front of you with all of your fingers together, and open your hand like a flower. We call this bloom, and this opens the start menu. But once you've opened the start menu, how do you actually select something? Well, on a traditional PC, you move a mouse around on your desk, and this moves a cursor around on your screen. With HoloLens, you move your head, and it moves a cursor over the world. We call this gaze. A gaze cursor will actually move over physical objects and holograms. When you're ready to select whatever is underneath the gaze cursor, you use our next gesture, which we call air tap. You simply raise your hand in front of you with your finger up, bring your finger all the way down to your thumb and back up, like this, and that will select whatever is underneath the gaze cursor. Of course, not all interactions with two-dimensional apps are so simple. This is why we give every two-dimensional app on Windows Holographic 3 tools that you can find at the top of the app in the app bar. These are the scroll tool, the drag tool, and the zoom tool. Here's how you use them. To use the scroll tool, begin by using gaze to target whatever it is that you want to scroll. Then begin making an air tap gesture, but don't bring your finger back up right away. Actually hold it and move your hand a little bit in whatever direction you'd like to scroll, and the app will begin scrolling that surface in that direction. Whenever it's done, just let go. To use the drag tool, this is great when you need to move something from one part of a hologram to another. So say I'm playing solitaire on my HoloLens, and I need to drag a card from one side of the screen to the other. I'll start by simply targeting the card that I want to move with gaze, make an air tap and hold gesture, and just pull it over with my hand. And whenever it's landed where I want to put it, I just let go. And the last tool is the zoom tool. You begin by targeting whatever it is you want to zoom. For example, the Windows Maps app, which is a great universal app on HoloLens. You target the map in this app, air tap and hold, just like you do with the scroll tool, and move your hand up a little bit to begin zooming in, or down a little bit to begin zooming out. And whenever you're done, you just let go. OK, so now you know everything that you need to know to use two-dimensional apps on HoloLens. Let's get to the fun stuff. Design considerations on how to actually make your app great on HoloLens. What does it mean to support gaze and gesture input? How do you make your app usable and legible and beautiful on HoloLens? And what are the other differences in the operating system that you need to keep in mind? Well, the developers in the crowd are probably wondering, what do I need to do to support this gaze and gesture input? This sounds pretty complicated. We actually worked really hard to make this incredibly easy for you. Gaze and gesture input actually get mapped into two-dimensional apps as touch events. If your app is touch-friendly, you probably don't need to do anything for gaze and gesture input to work. So all of your existing touch-friendly UI will work just fine. You don't need to learn anything about head tracking or hand tracking or gesture recognition. We do all of that for you. This means that when you gaze at a button and you make an air tap gesture, the app is receiving a touch event, like a user just tapped on a touch screen. And with the scroll gesture, the app is just receiving a series of swipe events as if a user is swiping around on a touch screen. And with drag, whatever movement you make through the air with your hand, the app receives that very same touch event with exactly the same shape that you drew in the air. With the zoom tool, the app actually receives 2 simultaneous touch points that are either moving closer together to each other or further apart to emulate a user zooming in and out on a touch screen. I know this is kind of hard to visualize, so I'm actually going to demonstrate this for you with a live code example. Oops. So on that note, this is a great time to mention the HoloLens emulator. The HoloLens emulator is a great tool that you can use to start testing your app on Windows Holographic today. You don't need to wait until your HoloLens arrives. Just go to dev.windows.com and download it. It's totally free. All you need to do this is Visual Studio, which I'm sure you already have, the Windows 10 SDK, which I'm sure you already have, and the HoloLens emulator that's free on this website and incredibly easy to use. I'll show you how. And of course, you need your app that builds for x86. A lot of the documentation on this website will refer to things about Unity and 3D, and that's not necessary for two-dimensional universal apps. You also don't need your HoloLens to start testing on Windows Holographic today. You can start testing right away and submit your app and really have it fully validated for whenever you get your own device. So without further ado, let's do a quick demo. What I have here is a really basic universal Windows app that I wrote. It's very simple. I'm going to run it on my local desktop machine first. I wrote this on my desktop to run on my desktop, and I'll show you what the app is, and then I'll show you how it runs in the emulator. So this is a really basic Paint app that has some tools on the left side, different brush sizes I can choose a different color, and then I can doodle on the screen. In fact, it supports multi-touch as well. You guys aren't very impressed. That would have been like a standing applause in 2005. And of course, it uses some great universal contracts. Like I can use the share contract to actually send this magnificent creation. My wife received a lot of really bizarre emails from me when I was developing this. And you can also use the print contract to print off your drawing. But this is pretty uninteresting for you guys. Let me show you what it looks like when I run it in the HoloLens emulator. So it's really easy. I have the emulator already set up on this machine. I just go to this drop-down, and I actually select the HoloLens emulator. And it's going to start building it and deploying it to the HoloLens emulator that I have running here. Now, the HoloLens emulator is a tool that lets you interact with a virtual machine of Windows Holographic. So when you're using it, there's actually an entire copy of Windows Holographic running on your machine. But unfortunately, since you don't have the device with all of its sensors and its HPU, it doesn't have head tracking, it doesn't have hand tracking, it doesn't have gesture recognition, all this other cool science. So to interact with it, the HoloLens emulator actually uses mouse and keyboard input to simulate a user doing all of these things. Now, some of the controls in the HoloLens emulator are actually going to look very familiar to you guys, and I'll show you exactly how. Rather than looking around with my head as I would on a HoloLens, I use my mouse to look around. Rather than walking around with my feet in the world as I do using HoloLens, I use the W, A, S, and D keys. So it's kind of like Windows first-person shooter edition. So all those hours of playing Counter-Strike are finally paying off. Someone please tell my mom. So as you'll notice, this is basically the same app. It's exactly the same binary. You saw me hit run. I didn't make any code changes, and it's running in the HoloLens emulator. I'm not going to show you all of the keyboard and mouse shortcuts. You can look those up on the website, but I will try to explain for you exactly what I'm doing in terms of gesture input. So let's try to do the same thing that I did before. Let's select a big marker brush and actually a green color, and then I can use this paint app to demonstrate for you exactly how gesture inputs get mapped into touch inputs. So I'll use mouse to move the gaze over here. This would be a user looking over there. And now what I'm going to emulate is a user raising their right hand, air tapping and holding, and moving their hand to begin scrolling. And then now I'll actually use the mouse to gaze down at this green color, and I'll press a button that emulates a user air tapping. And let's scroll back up and select a big old marker. Okay, as I mentioned before, the scroll tool injects a series of touch events, like a user swiping continuously on a screen to scroll through a list really quickly. This is a paint app, so you can see exactly what those touch events look like. So now I'm going to emulate a user air tapping and holding, and moving their hand to the right a little bit, and moving around so you can sort of see what the input looks like. Now let's take a look at the drag tool. As I mentioned, this is the one where when a user air taps and holds and draws a path through the air, the app will get touch events that look just like the shape they drew in the air. So I'm going to draw something like this using the HoloLens emulator. I'm not very good at drawing with the mouse, apparently. And lastly, the zoom tool is the one that injects two simultaneous touch points, either moving away from each other or moving towards each other. So I'll emulate a user air tapping and holding and moving up a little bit, and then the user air tapping and holding and moving down a little bit. One other difference that you might notice in this app is that in the top left corner, the share button and the print button are actually missing. This isn't a bug, this is by design. And that's because HoloLens Development Edition right now does not support printing and it does not support sharing. And this app actually uses dynamic feature detection to determine which features are present on the version and platform of Windows that it's running. And it disables those buttons. I'll show you how to do that a little bit later. Oh, and in Visual Studio, you can also deploy directly to a HoloLens unit. Here's a quick video of me using this at my desk at work. So you can see this isn't just fakery on my PC. So let's move on to usability and legibility. You might be wondering, how big do I make text? What's the legibility of holograms? How big do I need to make buttons so users can target it using their heads? I mean, you all know how big to make a button for a touchscreen. You make it the size of the tip of your finger. But you're probably not very familiar yet with how users actually target things using gaze. This really boils down to one question, which is, how do I ensure that UI elements are appropriately sized? As seasoned Windows developers, this is probably a familiar question to you that you've already worked through on other devices, when you move to high DPI, when you move to big screens and small screens. So we worked really hard to make sure that you could utilize the existing code that you use to work around these problems. There's two techniques that I want to show you. The first is the scaling algorithm in Windows. The Windows scaling algorithm accounts for the pixel density and the viewing distance of the screen that you're using to make content bigger or smaller so it appears roughly consistent in size for the user. This all holds completely true for HoloLens as well. We've done a lot of user research on the legibility of holograms and how accurately people can target things by moving their heads. So we've selected a resolution and a scaling factor that makes sense and we think will be very usable on HoloLens. Typical HoloLens viewing distances are somewhere in the range of 20 to 110 inches. These are the kinds of ranges that people place holograms. But of course, you could put a hologram on a wall and walk very far away. The second technique that you need to use is responsive layout. Responsive layout is when an app detects how much screen real estate it has and changes its layout in response so that it makes the most sense on the screen size that you're using. And the Mail app is an excellent example of this. So the rightmost image that you see here, this is what you might see if you were to use the Mail app on, say, like a 13-inch laptop. You get 3 panes. You get one pane that has your folders and your accounts. You get another pane that has a list of your messages. And then you get a third pane where you actually read the messages. And this works very well. It's a great design. But as you go to a smaller and smaller screen, eventually it gets too crowded. It doesn't make sense anymore, and it becomes difficult to use. So you get to like an 8-inch tablet. You just can't fit 3 panes anymore. So in this case, the app actually collapses the leftmost pane into something that you open and close. And when you go to a very small screen, like a phone, it actually collapses into a single pane. And you only interact with one at a time. So you solve this problem through scaling and responsive layout. If you follow all the existing guidelines for the Universal Windows platform, you can rest assured that your touch-friendly targets in your app are also gaze-friendly targets, and we suggest roughly 48 effective pixels. 2-dimensional apps are given a resolution of 1280 by 720 with a 150% scaling factor. This makes things large enough that users can effectively target it, click on it, and read things. So all of the existing guidelines that you know already from design.windows.com apply. If you want to learn more about this, some additional reading on responsive layout, I'd highly recommend checking out design.windows.com. Covers this in great depth. And actually last year at Build, my friend Carmen Zlatoff gave an excellent breakout session about UX patterns and responsive techniques. So making an app that scales really well from screens from the very small to the very large and the holographic, I highly recommend checking out this talk. Some other considerations, like color and theme considerations. HoloLens's display is like nothing you've ever used before. It is not an opaque surface that emits or reflects light. It is a transparent surface that emits light. This lets us do some really cool things. It creates holograms that seem like they exist in the world with you, and you can continue seeing the world, so you're not tripping over the coffee table or the cat or whatever else. But it does have one downside. It can't project pure black, because black is the absence of light. This sounds like it's going to be a huge problem, but actually for the majority of apps, we find it really isn't. It's quite an interesting optical illusion. If you have an app that, for example, is white and has black text on it, technically that black text on our display becomes see-through, and you can see the world through it. But when your eye is focused on the focal plane of the app, your eye perceives small amounts of those little gaps as black. It's quite an interesting trick. Where it falls down is if you have an app that has huge swaths of flat, pure black. If you have an app that has black background and white text on top of that, a HoloLens user will perceive this as white text floating in the air. Generally not a problem unless you have black backgrounds, but it's something worth thinking about. Very dark UI in general can also be a problem in extremely bright spaces. So if you are in very direct sunlight sitting by a window, a dark app can begin to get a little bit washed out. I'm going to show you a simulated rendering of what this looks like, and I do want to caveat that this is my attempt at faking what it looks like in a 2-dimensional medium. This is something you really need to try for yourself to understand exactly what holograms look like, but I want to get a point across here. So imagine for a moment you're in a very brightly lit room with these two guys, and you want to look at vacation photos. So you pull up your OneDrive app, you go to your photo roll, and you pick a photo to look at. It might look something a little bit like this. Again, this is a simulated rendering. This was not shot through a HoloLens. It's a little bit see-through, and it's a bit hard to tell here, but very dark areas are more see-through because there's less light being shone into your eyes. There are some other interesting platform differences that you may want to consider when you're designing your app for HoloLens. For example, text input. Text input in two-dimensional apps works just like any other device that doesn't have a physical keyboard. When you select any control that accepts text input, you'll actually get a soft keyboard that comes up. Except on HoloLens, this is a holographic keyboard that appears in front of you, and you can interact with it using gaze, gesture, and voice. It's fine for typing small amounts of text. It's not bad. I like using it every day. I would say personally, I can't type as fast on it as I can on a phone, but I can type a little bit faster on it than I can with an Xbox gamepad on an Xbox. Now, the HoloLens keyboard also features dictation. There is a microphone button on it, so you can air tap on that and just start speaking to HoloLens. And it has a great microphone array that does a really good job of capturing everything that you've said. And of course, HoloLens is a Windows 10 device. You can go into the Settings app, the exact same Settings app that you see on your desktop machine or your Windows phone, and you can pair with it a Bluetooth keyboard. This is what I did when I did my taxes in holographic Excel. The universal camera APIs actually function exactly as they do on other platforms, but there are some interesting considerations about how the user interacts with it. Unlike other Windows platforms where you can use the camera APIs and the user is free to point it wherever they want and tap a button, keep in mind that the camera on the HoloLens is on the user's forehead facing out. So it captures whatever they see. It's pretty cool. But this also means that for a user to actually frame a picture, it's difficult for them to interact with the app because they have to point their head to interact with the app as well. So if taking pictures is a core feature of your application, you might want to consider changing the behavior a little bit for HoloLens in this case. You might make a button where you air tap it, and 3 or 5 seconds later, it takes the picture. Or, even better, you can use HoloLens's voice input capabilities to use a voice keyword to take the picture. And I'll show you how to do that in a little bit as well. Now, external peripherals on HoloLens. Bluetooth right now, it works for keyboards, as I mentioned, works great. The HoloLens clicker that comes in the box, and gamepads work via raw HID input. USB peripherals are not supported. Sorry, you can't hook up your dot matrix printer to the computer on your face. The USB port is used only for charging and for debugging. So next, adapting app behavior for HoloLens. One of the great benefits of the universal Windows platform is that you can write an app once and ship it to tons of different devices. That family of devices is growing. But what if you need the app to behave a little bit differently on one device versus another? Maybe because the capabilities of one platform is different, or maybe because the way the user interacts with it is a little bit different. What we really don't want you to have to do is to fork your code base and create multiple versions that you have to support. That's just a world of hurt that we don't want you to get into. So I'll cover some of this. I'll also show you how to detect features dynamically and adapt that behavior at runtime. And then lastly, I'll show you how to utilize some HoloLens capabilities with another live code demo. So, dynamically adapting behavior. Some of the reasons why you might want to do this include whether or not the feature set is present on the particular Windows platform you're using. As I mentioned, on HoloLens, we don't currently support share or print. Or maybe feature detection based on Windows version. What if we add share and print in the future? Wouldn't that be cool if your app could just light up and take advantage of these new operating system features without you having to monitor what features are on what platform and ship new versions? I think that'd be pretty great. And as I mentioned, there may also be business decisions about how different Windows platforms are used, and you might want to pivot on that. Whenever you're on MSDN and reading any API documentation, I would encourage you to scroll down and look for this little table that you'll see at the bottom that says what device family that API is present on. If it says it's available on Universal, you're good to go. That API is present on HoloLens. If it says holographic, you're also good to go, although I think all of our holographic APIs are part of the Universal family today. If it says mobile or desktop, that's not going to be present on HoloLens. Granted, I'll show you, it's very easy to actually detect exactly which ones are present. So there are a few different ways to do this. The recommended way is to use the metadata.api information API to determine which APIs and API contracts are present. However, that doesn't always necessarily mean they're functional, and there's a very interesting nuance here. Many of these type names will also support something called isSupported that will help tell you whether or not that specific API is functional. So this is a weird distinction. There are APIs present in the universal platform that aren't fully functional on every universal device. I mentioned share and print. These are both present on HoloLens, but not functional. So what does that mean? This means the APIs aren't going to do anything bad. You don't have to remove the code when running on HoloLens. It's not going to crash or throw weird exceptions or anything like that, but it's not going to successfully print or share. So you can safely leave that code in your app, and it's not going to do anything really weird, but you may have some non-functional features. There is another way to do it, which is checking the Windows device family name, and we really don't want people to do this. There's a lot of reasons for it, and let's move on to that next. So you can detect that your app is running on HoloLens. It's not something that we encourage. We would really rather have people dynamically detect features, but there are some good reasons for it. For example, there are business decisions. I mentioned earlier that the Windows Maps app is a really great universal app that runs on HoloLens. And this is true. It's an awesome app. It's great. But it has a feature for turn-by-turn driving directions. And it didn't seem like a very good idea for us to tell people to wear their HoloLenses while driving and placing a hologram potentially in front of them and taking a hand off the steering wheel to AirTab. It seemed like something we didn't want to encourage. So in this particular case, we detected that the app was running on HoloLens, and we disabled that feature. Another time that you might want to actually detect the platform specifically is if you find any platform-specific bugs. HoloLens is a development edition. You might find some issues, and I want to give you the right path forward. So if you do find issues, you're not blocked. You can work around them. Of course, if you find issues, please go to forums.hololens.com and work with us. Give us feedback and tell us what you like and what you don't like. Now, detection of the platform name is highly discouraged for a few reasons. One is that it's incredibly fragile. The list of platforms and their names will evolve. We don't make any guarantees that this is going to remain constant. This is really not something that we want people using for this purpose. It's also hard to maintain. Do you really want to be in the game of managing which platforms support which features over time? That's not something that I think anybody wants to sign up for. Now, if you absolutely must, this is the API that you can use to determine that your app is running on Windows Holographic. There's a version info.deviceFamily will return windows.holographic. So additional reading on feature detection. Brent Rector at Microsoft did a great talk last year all about how to detect features, and he used this very cheeky name for his talk. He also did a really great blog post about dynamically detecting features with API contracts. OK, let's get to some more fun stuff with HoloLens. So, voice input. You can speak to your HoloLens. It has a great set of microphone arrays that are constantly listening to you. When you're looking at something, you can say select, and it works just like AirTab. And this is particularly great for scenarios where my hands are busy and I don't want to take my hands off whatever I'm doing. As I mentioned earlier, HoloLens is really great for multitasking between the physical and digital world. So when I was working on my car, I didn't have to drop my wrenches to turn to the next page of my PDF. We also expose for you a set of voice APIs that are really great for voice shortcuts and for recognizing phrases and sentences. So if I chose to optimize my little Paint app a little bit further for HoloLens, I could have commands like bigger brush, smaller brush, green, red, and so forth. You could also use it for capturing entire sentences. This is all available for you in the Windows Media Speech Recognizer namespace, and there's further reading available at this link here. So let's do another live code demo. Earlier, I mentioned an app for musicians that would enable them to read sheet music without missing a beat because they can turn to the next page by using gaze. This is a real scenario. I play the guitar, and anyone else here who plays the guitar knows that there's a lot of great instructional information available online. But it's incredibly awkward to hold the guitar, sitting on the couch, hunched over it, with a laptop on the coffee table. It's really difficult. It's a bad posture. You need to keep touching the touchpad so the screen doesn't go to sleep. And then when you need to go to the next page, you have to take your hands off the instrument again. So I thought it would be really cool to actually leverage HoloLens to make this much better. So here I can simply open my other project. So this example will also show some other interesting differences with HoloLens. So first, let me run it on my local machine. Now, this app is not something I don't think anybody would download this from the Windows Store. It basically just loads a PDF on desktop. So I can go here and I can open up this JSBox Sonata, or not. There we go. And you can scroll around, and it's not particularly interesting. But I've made some tweaks to this app so that when it's running on HoloLens or the HoloLens emulator, it actually responds to the user's gaze. It detects where the user is looking without needing them to air tap or say anything. So imagine for a minute that you're a musician, you've got your hands on the piano or the guitar or whatever it is, and you're playing your music, and there's a certain rhythm happening, and you get to the end of the page, and you need to turn to the next page, and you really don't want to take your hands off the instrument. Wouldn't that be cool if you could just look at the right spot and automatically have it scroll for you? So another difference that you're going to see in HoloLens here is that this app uses the file picker contract. When you use things like file open and file save, the behavior is a little bit different. This is because HoloLens doesn't have a native file picker. It actually relies on apps that use the file picker contract. In this particular example, I already have the OneDrive app installed on my emulator here. So when I hit open, it opens up the OneDrive app. And now using the emulator, I'm going to emulate a user air tapping and holding and moving their hand to scroll down in here. And I can find that very same PDF. And open it. Now, this looks exactly as it did on the desktop, but I'm now going to emulate a user looking down at the bottom of the page. No air tap, no gesture injection, just only looking with their head. So there you have it. If you wish to do this, let me switch back to here. Oh, and here's a quick example of it actually working in a HoloLens as well, so you know that I'm not faking it on my desktop. This is completely hands-free. If you wish to do this, what you look for is pointer entered events where the pointer device type indicates that the user is using touch, but also that the touch point is not in contact. This is a little bit peculiar. This is suggesting that the user is somehow hovering and using touch at the same time, which isn't something you can do with regular touchscreens today, but this is how you can detect gaze. Another place where we chose to use this is actually the Windows Store app. They have a control at the top that's a carousel control that shows these very large images advertising the various apps available for your device. In this case, this is the holographic Skype app. This control was a little bit tricky to interact with using the gestures due to the way that it automatically scrolls periodically. So we decided to enable the flippers, the little buttons that you see left and right, for scrolling left and right in the control. Usually these only come up for mouse users, but in the Store app in this case, we enabled it for gaze as well. Some other differences in Windows Holographic today include these things. Right now, in the mixed world, only one app can run at a time. When you use an app and it's active and then you move to another app, the previous app becomes suspended, and we take a screenshot of it. So you can still multitask between apps, but they're not running at exactly the same time. As I mentioned before, the share contract also is not working. Notifications like local push, toast, live tiles, these are things that are not functional at this moment, but we're thinking about. There is a complete list that we'll be maintaining on this website. Remember, this is a starting point. We'll be making fast progress, and do give us feedback if there are particular things that you want sooner than later. OK, so at this point, you have a great app that works on HoloLens. How do you actually distribute it to your users? How does the Windows Store work on HoloLens? I'll give you an overview of how the Windows Store works, how to publish your app, and some of the nuances when it comes to targeting apps at various Windows platforms. So the Store app itself is another universal app. In fact, the app running on the HoloLens is exactly the same binary that you would get on your desktop PC or a Windows phone. It displays different content. It tells the service that it's a HoloLens, and the service gives it different contents to promote back. And it only shows Windows Universal and Windows Holographic apps. Don't worry, if you are already a Universal app developer, we are not opting your apps into the store without your permission. You decide whether or not your app is available in the HoloLens store. So the process for submitting an app to HoloLens Store is exactly the same as submitting any other UWP app. You go to dev.windows.com, and you go through the submission process there. There's one page that looks a little bit different starting 2 days ago. You might be familiar with this screen, where you select which platforms you want your app to be available on. Starting on the 30th, there is now a third checkbox on that list called holographic. It's unchecked by default because we don't want people submitting their apps to the HoloLens store without testing it. Fortunately, it's really free and easy to do that. But when you're ready to submit your app and make it available in HoloLens, just check that checkbox in a new submission, hit OK, and you're done. You'll notice also at the bottom that there's a set of radio buttons. So you can say, yes, let Microsoft decide whether to make this app available on any future device families. We take this seriously, and actually that radio button has been there for quite some time. We actually use this to figure out which apps we might want to include in the HoloLens store at launch. So we tested a lot of apps and figured out which ones would be great to start off our store with. And if you're a universal app developer and you've marked yes for this radio button, and your app works great in HoloLens, you will probably have an email waiting in your inbox in the next couple of days to let you know that your app's available on HoloLens. And if you don't want it to be, we'll show you how to take it down. OK, so targeting apps at different platforms. You're probably familiar already with your app manifest. This is where you specify what platforms and all of the details about how your app runs. In here, there's a place where you can specify the target device family of your app package. If you specify that it is Windows Universal, you're saying it can run on any universal device. This package can be installed on HoloLens and it will work. However, products can have multiple app packages. So if you have an app that is completely different on one device versus another, you can actually do this as well without creating a separate product in the store. So any conflicts are resolved via version number, and I'll show you exactly what that looks like. So say you have a two-dimensional app that you've already shipped for Windows Phone and Windows Desktop, and you've decided to make a holographic app in Unity for HoloLens. So it's a completely different experience. But you don't actually want to create a separate product. It's the same app. It's just a better experience on HoloLens. In this case, you'll have two app packages. You might have one that's the two-dimensional app for Windows and Windows Phone. And you'll have another one that's the holographic app for HoloLens. In your manifest here, you can specify Windows.Universal as the target device family for the two-dimensional app. And you can specify Windows.Holographic for the target device family for the HoloLens app. To make sure that HoloLens users get the HoloLens package and not the two-dimensional package, you'll want to make sure you give it a higher version number. All conflicts are resolved through version numbers. OK, we covered a lot today. Let's start wrapping up. So we talked about why two-dimensional apps are awesome on HoloLens. You can go beyond the screen. Your apps aren't trapped and encumbered inside of this physical thing that you have to carry around. You can put it anywhere. You can keep apps where they matter the most to you. You can use it comfortably in any posture, whether that's sitting at a desk, lying back on your couch, floating in outer space. You could use a two-dimensional app on HoloLens while you're doing yoga. And that's a good thing because it's also completely hands-free. So you can do downward-facing dog while you're wearing HoloLens if you really wanted to. So HoloLens makes it really great for multitasking between the physical world and the digital world. If you make a line of business app where your users are doing exactly this already with tablets, think about how their life could be so much easier if their hands were completely free. All of your existing tools for UWP apps actually work on HoloLens, and all of the existing guidelines apply as well. So you can rest assured that if your app is touch-friendly, it's probably gesture-friendly as well. Now, building two-dimensional apps and bringing existing two-dimensional apps to HoloLens is free and really easy. So you can get the emulator at dev.windows.com/holographic. You can download it today. It's incredibly easy to use, and you can begin testing your app and sending it out to the Windows Store before you've even received your HoloLens. And in the event that you do need to make changes to your app to behave differently on HoloLens versus other platforms, you don't have to fork your code base. That's just a world of hurt. It's bad for everybody. You can make your app dynamically adapt and detect the features of the host OS and do things differently at runtime. And then, of course, you can publish your two-dimensional app to the Windows Store exactly as you do with any other two-dimensional app. So please, tell us what you think. Tell us what you like. Tell us what you don't like. This is the HoloLens Development Edition. It's made for you. So go to forums.hololens.com, give us feedback, help us understand what it is that you want to make your apps better on HoloLens. So I've showed you everything that you need to know today on how to make your two-dimensional app work on HoloLens. And I can't wait to see what you have to show us. Thank you for attending my session today. I hope you enjoyed it as much as I did. Oh, and our developer researchers will be waiting outside. If you want to earn some more challenge points, hang out by the flash voting sign, and they'll just take a couple minutes of your time. If you have any questions, please step up to a microphone. I'd be happy to take them.
Oh, okay. I'll do it. Hi. So I have a long paragraph, I guess. But, okay. So you mentioned at the start of the session about running, a huge video player, with your HoloLens. So I'm a co-contributor with VLC, and so we're getting some HoloLenses because we want to build holographic video players, which is great,
Awesome.
right? We need things like background audio, and we need video playback stuff to work. And you said multiple concurrent apps aren't working right now, I think, which is kind of problematic because if you want to have. But what is working then? Do you have background audio? Is that stuff? Because we have that in our app. If I switch to another one, if I am listening to music or whatever, and I want to go to Edge, does it still run, or will it just suspend, or is there any specifics on that, or no?
I'm very happy to say that background audio actually is fully supported today.
Okay.
So I use Groove Music all the time on my HoloLens. It's fantastic. I don't know all the details of everything in VLC, but I would actually love to chat with you more about that.
Oh, awesome.
So check out the HoloLens emulator. It's a very accurate representation of what does and doesn't work on HoloLens.
Okay, cool. But does the emulator let us have multiple apps running at the same time so we can simulate, or no?
It has exactly the same behavior as HoloLens.
Okay,
It's
all right.
literally a VM of the same OS.
Awesome. So a few other things then. Can we store files on the device itself? Does it have known folders and the same sort of API for video, audio, storing files, or no?
There definitely are APIs for local file storage, all the kinds of things that you would expect in terms of local app data and
Okay.
your ability to store things. In terms of known folders, I don't recall off the top of my head. There is no file explorer,
Okay.
so the file system is not exposed to the user.
All right. But can users get videos and stuff on the device themselves, and then can we tap into that, and all apps can do that, or is it our specific app is the only one who can do these? You have to store it in the app. Do you know what I mean?
Yeah, I think it would be you'd have to store in the app in this particular case.
Okay.
Yeah, there's no good way right now to copy files over. I do highly recommend checking out how OneDrive works for you. I understand video streaming is a very unique thing and very special in many ways.
Yes.
But that's a good problem. And personally, I love VLC, and I really look forward to seeing it on HoloLens.
Yeah. And then the last one I have is kind of to do with VLC, but so you mentioned if we have a holographic, a Unity app and our UWP app. But will the users be, let's say we want to have both. Let's say we want to have a UWP app that works great and they want a 2D experience, or we want to have a 3D experience as well with the same app package. Can we have a scenario where users can pick which one they want, or is it we have to separate it? I know that sounds like a weird scenario, but I have had that situation with people wanting oh, I want the Windows 8 version for whatever reason of an app instead of a Windows 10 one.
So just so I understand, the scenario is you have both the Unity holographic version of a VLC, and you also have...
let's say we wanted to do that.
What I would recommend in that particular case is actually creating a separate product in the store.
Okay, yeah.
I would suggest making so you had VLC holographic or something like that.
Right.
You could, in theory, bundle things into the same app package and have it dynamically change. But the problem is that once you start using Unity, I suspect that you'll end up having a lot of code specific to the Unity one.
Oh, yeah.
And that would just bloat your package.
Yeah, but okay. That's fine. I just wanted to see if there was a scenario for it.
Right.
All right, that's all I had.
Cool.
Thank you.
Hi. First question I had was regarding the scaling, the effective scaling.
Yes.
I'm pretty familiar how it works on the screen and the phone and the Xbox even. But one thing I'm confused about is, that distance aspect of it, right? If I created that hologram right in front of me and it's tablet sized, let's say I put it on a wall, right? And the wall is right close to me, so maybe it looks like a computer monitor, and then I step away from it. Does it adapt into a TV display, or how does that work?
No, the resolution and the scaling factor of apps are fixed, no matter what the viewing distance is and no matter what the size is. If you have specific suggestions or features, I would highly encourage you to go to the forums and actually post that, because this is something we're very actively listening on the forums for suggestions and feedback.
Cool. The other question I had was regarding the inputs. I was curious why you're using touch events when a lot of the stuff seems very similar to a mouse. Your gazing is kind of like a mouse over, and then kind of the scrolling is kind of like a mouse wheel. you have any input into that?
I don't have all the history in that particular decision, so sorry, I'm afraid I can't answer that.
Okay. And related to that was like, the gaze is your pointer, right?
Yep.
I tried HoloLens once. It seems like it gets a little bit unnatural because I don't always turn my head to gaze at something differently, So I was wondering if you can like actually track a hand, kind of like the Xbox did with Kinect.
We don't allow targeting with hand at the moment.
Okay.
I will say you do get used to targeting with gaze. I understand what you're saying. I hear your feedback. But it is something you get used to pretty quickly. Right now, we also support input via keyboard. There's other things we're thinking about as well.
Okay. And it's just one hand, right? It's not both?
You can use either hand, but currently we don't support multiple hands at the same time.
Okay. Thank you.
You're welcome. Yes?
So I have a question about accessibility.
Yep.
If you don't have fingers, are there alternate gestures you could do for Bloom?
Ooh, that's a good question. If you don't have any fingers, what can you do for Bloom?
Or missing fingers?
One thing that you could do in that particular case is if you had a Bluetooth keyboard or a device that at least had the Bluetooth keyboard profile, the Windows key on that would actually function for you.
Okay, but there's no way to do alternate gestures at this time for accessibility?
For accessibility, no, and it's really unfortunate. I think that HoloLens has incredible possibilities for the accessibility community, but right now in its current state, it's a little bit limited there.
Okay, thanks.
Great, you're welcome.
Are there any plans to support sign language as an alternate keyboard input?
I don't know of any plans in that area. I can't disclose anything about future versions. It's a really cool idea. I love it.
Hi. So it's interesting that you mentioned that the dark theme of it is not encouraged. If you think about it, Windows 8 and Windows 10, generally encourage the dark theme as the default. So isn't that some sort of step back from that? And if we had to plan for the future for this, would you say that we need to introduce a light theme so that we can start having things encouraged for HoloLens?
So if your app dynamically themes, you're probably already using a Windows API that requests for exactly which theme the user is using. Because in Windows, you can choose dark or light. On HoloLens, those APIs will always return light. Unfortunately, this is just one particular limitation of holographic displays. It works a little bit better with light apps than dark apps.
OK, thank you.
My question is about windowing. Universal apps can span multiple separate windows, secondary windows. First, is it supported, and what the experience like?
Yes, if you have an app that attempts to open a second window, I believe it will actually put you in what we call placement mode, where it pops up another window and asks you where you want to put it.
Okay.
Unfortunately, the nuance is that once you activate that and place it, the previous one becomes suspended.
So no. Thanks.
Hey, for the keynote, they showed that you could now package Win32 and WPF applications as universal apps. What's the story with HoloLens? Will you support WPF embedded in universal apps or things like that?
You're speaking of what they call universal desktop apps?
I don't remember the name, but it was the new feature that you could package an old application inside of a universal Windows app.
Right.
Centennial, yeah, true.
Yes, I'm not very familiar with that technology, so I'm afraid I don't definitively know the answer. I would be surprised if it worked.
Okay. Hey, thanks.
You may have actually just answered it. I was just wondering that video where the guy walks into the room and he has weather here, media player here, Skype here. Is that a reality? Can you actually you don't actually have these three apps running simultaneously within your view at any given time, do you?
Well, when you place them, when an app becomes suspended, it gets a screenshot taken of whatever it was before. So you can continue multitasking. When you tap on it, it reactivates it. So you can't actually have the apps placed everywhere. So for example, if I place the weather app, it will be there, but it won't be live updating if it's not the app running at the time.
And you just
tap on it, and then it reactivates.
Okay. Thanks.
Kind of similar to that, actually. In that same demo, you've got sort of the weather widget. You've got the dog widget. Are those separate apps working in mixed mode?
Those would be separate apps in the mixed world, as we call it.
So I was in the documentation I was reading about, it was saying with the one app at a time limit, you had to go into holographic mode for your Unity app and mixed mode for your 2D apps. How do you mix different holographic Unity apps together? Is that something there's special APIs for, or is it you just don't request the I guess, getting out of mixed mode?
So you currently can't have multiple exclusive Unity apps running at a time. When a Unity app runs, it renders everything around you, and all of your mixed world contents actually disappear.
So how does that work in the demo then? How could I create a widget that works
in
mixed
the three-dimensional widgets that exist in the world. Unfortunately, that's not something that we're exposing publicly yet. It's something we're thinking about and working on, but there are no public APIs for doing that right now.
Okay.
is there like a float with me concept? So while you're working at your Chilton PDF manual, as you're working on your car, that it will stay in the upper right or lower right? That is way as you move your head to get different positions, that manual's still near.
There is not currently. Right now, when you place an app, it remains exactly where you left it in the world, and it doesn't move. When I was using it in my car, as you know, like trying to place a laptop in a car engine bay isn't exactly a good idea. It's fixed in a very specific spot. So it was like a magical floating tablet, essentially.
Okay. And is there any plans to add like a float with me API?
I can't say anything about future
Okay.
plans, sorry.
Okay.
Wish I could.
Another question, resize implementation. So I can basically select the resize tool and resize the window. Is there any way to limit the resizing, or?
No, actually, two-dimensional apps, they don't have any notion of what's happening outside of their little two-dimensional world. They don't know that they're being resized. They don't know whether they're large or small. They don't know where in the world they're placed.
Okay. So no way to response, right?
Hey, g'day. With the emulator, can we put a texture map in the background so we can take like pictures of the outside world and then apply in the emulator?
I'm not sure I understand the question, sorry.
So in the emulator, I saw that you had the black background with your app in it. Can we apply?
Oh, so you could see what the real world looks like.
You know that black issue you're talking about. So imagine you take your phone, do like a photosynth style capture, put that in the background of the emulator, and then you can kind of simulate your desktop outside conditions really easily.
That's actually a really great idea. There's no way to do that right now. I think it would be really excellent if the emulator would help us visualize what something looks like in the world. Because actually, let me pull it back up for a second.
You know, come thinking like, you know, you got day, night, all these different conditions where your app's going to be used, but, you know, I don't want to dev at 10 o'clock at night.
Yeah, so here, let me pull open the emulator also, because right now in this app, you see just nothing but black around you. But actually, the HoloLens emulator is emulating all of HoloLens's inputs. It's actually sending the OS a full map of what a pre-baked, predefined world looks like. So if I were to actually look over here in AirTap, it'll actually show you the surface reconstruction of the world that we pre-mapped and saved here. So I see what you're saying. It's a little bit hard to visualize exactly how the app is being used in the real world. It doesn't really represent for you fully what it looks like. It would be a really cool feature if it would actually show you, you know, a simulated room or whatever, and actually have a little bit of the.
Because in the case of those blacks that you said can't render black, then you could, when you design your app early on, identify those issues.
I see what you're saying. Unfortunately, I don't think it'll ever be easy for you to really correctly simulate how the blacks are perceived without using an actual HoloLens device. The issue being here, if I were to take this and plunk it into some sort of a photo editing tool and select all the black and delete it and put something back there, it's really not how you perceive it as a real user. It's quite an amazing optical illusion where when your eyes focus on the focal plane, small amounts of that cut out, you really perceive it as black. So I think that's something that you're going to have to use a real HoloLens for.
Thanks.
Sorry, just time for one more question.
Okay, I was just wondering, in the demo that they had in the day 2 keynote with the Caterpillar thing, was that 2 separate apps, one running on the Surface and one running on the HoloLens? Or is that something you can do as a single UWP app?
Sorry, I'm not familiar with the exact demo that you're referring to.
There was a big, I guess, digger caterpillar thing with augmented reality where they looked at a picture and it came out on the HoloLens and they dropped it on the stage.
Oh, sorry, I don't know the specific details of that particular demo.
Okay, I guess, I mean, the underlying question is, can you make a single app that works in 2D, but then when you put on the HoloLens, you can pull a piece out of it in 3D?
It is possible to have an app that starts off as a two-dimensional app and can switch into Unity 3D mode, and this is documented on the website. I haven't personally done it, so I'm not intimately familiar with the details, but you can switch between flat and exclusive 3D modes.
Within the HoloLens in real time? Oh, okay.
Yes.
Great. Thank you.
All right, thank you very much. If you have any more questions, I'd be happy to answer them out over here.